background that the government commission report that the communities, certain communities such as South Asian community, lack the information and guidance, particularly for the youngsters and even the parents. So in that idea, we started this series of career guidance webinars to help our youngsters, particularly, and the parents to reaching the right decision in their career. And today we have a talk on IT and the computer science. And we have two very experienced speakers, Arslan and Muhammad Rafiq. And Rafiq Bhai is our lot of help in our IT and the backbone of our 3Meem Foundation. And he has, mashallah, given a lot of time and hard work to establish this career guidance webinars as well. So without any delay, I will ask, I think Arslan, you go first, and I think start the initial presentation, followed by Rafiq Bhai. He will give the input from the industrial point of view of obviously its application and the job perspective. So without any delay, I will ask Arslan to start the presentation. Thank you.
Yep. Hello and assalamu alaikum to everyone. I'll start off. So a bit about myself. My name is Arslan and I graduated in 2015 from De Montfort University with a bachelor's in artificial intelligence with robotics. It was a 4-year course with 1 year in industry, which was quite helpful for me. And since I've graduated, I worked in various positions in various jobs. And currently I am a full stack developer, which means I work in all aspects of the development at Barclays Bank within the frauds team. So whenever you make a loans application with Barclays, that goes through a system that I'm working on, which basically tries to check if the applicant's done any fraud. So that's what I am currently doing. So first slide is who should choose IT or computing? So IT, if you want to go into that field, it's very interesting and it's quite like a fun field to be in. But you really have to be passionate about it because it's a lot of hard work, a lot of learning. And unless you're not passionate within that field, you would struggle. You see this a lot at university. A lot of people join IT courses, but within the first term, they give up and they change courses because unless you're interested, it can be quite difficult field to get into. But if you're interested in technology, you like to be challenged, you like latest technology, it's really good, and that's what you need to be. Also, with IT and computing, you need to be a really good team worker because once you get into the industry, it's very unlikely you'll be working on your own. You're always part of a team. In majority of the jobs out there, you're working as part of a team and you have to learn to work with others really well because in IT, it just isn't about the software. This is something that Rafiq Bhai will get into, but there's lots of different sections within IT, and everyone from those different sections, like the developers, the analysts, the testers, they all have to work together in order to build the systems. And unless you're not a good team worker, it can be quite a challenging environment to be in. So the types of courses in IT, as I've mentioned, there is lots of different fields. So because of that, there is lots of different courses available. A lot of them share the same core foundations, but then they branch off into different sections. So you have computer science, information systems, software engineering, AI, games development, and things like that. So depending on your interests, you can pick different courses. Some are more technical than others, like computer science, for example, or games development are very technical courses. So if you interested in coding and the technical side, those courses are really useful. But if you're more into analyzing and requirements gathering, you can have courses like information systems, which is more documentation and things like that. So depending on your interests and your skills, you can see or you can choose different courses. And within those courses, there's different types. So you have like the standard 3-year BSc courses, but then you have 4-year courses that or give you an opportunity to have 1 year in the industry, and that can be very helpful. It's like a good way to get your door into jobs. That's what I did. I did a 4-year course which included 1 year within a company, and since I did quite well at that company after I graduated, they said I could join back. So those type of courses are very useful. But there's also 4-year courses where, as well as doing the BSc, you can do masters as well, which gives you a higher degree of understanding. And if you want to go towards the more academic side, that's like a good course to choose. And what I would recommend is do as much research as possible on the different courses and like the different types. And all of this information is widely available. If you just Google UCAS Computer Science, that's a UCAS website. It offers a lot of information. It gives you links to different universities where you can read up. And really, like, if someone wants to get the information, it's out there. It's just a case of spending a bit of time and doing research. And for that, UCAS is a really good resource. Obviously, the entry requirements for the various courses really depends on what university you're targeting, but the range generally for A levels is between CDD and AAA, and it doesn't really matter for a lot of universities what those A levels are. But once again, it depends. For some of the more higher ranked universities, they tend to like people having A-level maths and obviously better grades. But it really doesn't matter. Like, to get into computing, it's just a case of having 3 A levels and being interested, and that's really what unis look for. Obviously, with getting into uni, it's beneficial to have at least 5 GCSEs. And as I mentioned, some of the higher ranked universities, they tend to see if you've done quite well in maths. So that's quite important. And as alternative, if you've done BTech, if you haven't done A levels, BTech level 3, a lot of the universities, they accept that as well. But I would say before applying anywhere, please have a look on UCAS and on the university websites. They provide all the information you need and all the various grade boundaries. Obviously, when you are applying for university, you need to have a good personal statement. It's done as part of your UCAS application. And the personal statement is quite generic. All the universities, not just for IT, for other courses as well, are looking for a lot of the same things. So in your personal statement, you have to provide evidence that you're interested in IT and that you've done something in your spare time related to technology, IT. It needs to be written well in good English. And you need to show your personal skills as well. You need to show that you can work as an individual, you can work as a team, and you really have to show that you're interested. That's the main thing, I would say. And that's all from my side. And now I'll hand over to Mr. Rafiq.
Thank you. Assalamu alaikum, everybody. My name is Mohammed Rafiq. I have a master's degree in computer science, and I work as a software consultant to various business in the northwest of England, most in various industries like government sectors, retail industries, and warehouses, e-commerce firms, and various different industries I have worked. And lastly, I was working for the European Commission, and currently I'm working for the government of Scotland via a consultancy. I'm a software engineer by base profession, but I have grown up to become a software consultant now to advise various businesses and help them develop solutions to address their business problems. So today I will be talking a bit about what does it take to be a software engineer, and what are the different roles in a software engineer, and what do you need to study or what do you need to do to begin to adopt to a particular role, what are the various salaries involved, how the industry is evolving. I will touch on these subjects briefly. I'm not going into any vendor specific technologies. I'll keep it generic. It's a very short time to cover all of it, but I'll try to give you as much as possible in this short time. So who is a software engineer? On your screen, you can see a guy seated in a dark room looking at the black screen where numbers are scrolling. Is this a software engineer? This is what most movies project, like Matrix and things like that. Does it not sound to be so boring, dull, and tiring to sit all day in front of a computer and just look at numbers falling down on your screen? Is a software engineer such a boring role? No. There are various roles within software engineer. It is as interesting, and coding is just one part of it. Doing programs to develop software solutions is just one part of it. There are various other roles as well, and one can take up a career in those roles based on your preferences. And I'm going to talk about few of them today. So who is a software engineer? A software engineer is a person who writes software or who does coding in the computer to address a business problem. A business problem could be, for example, a payroll system. When an employee joins an organization, every month the payroll needs to be paid. His payroll needs to be calculated based on the expenses he has incurred. This is one small example of a business application. It could be an online e-commerce website like Amazon. Just a disclaimer, I'm not supporting any particular vendor. I'm just giving a very common example. Amazon.com, if you want to buy something, there are a lot of things that goes behind the scenes to make it work. Various parts that come together. It's a quite detailed software engineering practices are involved, and we'll look into them one by one. So e-commerce websites is one application, one example of an application. If you want to fly to somewhere, you book your tickets. So that's a ticket booking system. So these are some examples of the softwares that a software engineer develops. It is never a one-man job. One person does not develop everything. There's a huge team of people involved. Each has different roles, starting from junior developer, senior developer, business analyst, people who interact with the business, people who do the sales part of it. There are various roles. And one misnomer about IT industry is every role is a technical role. That is wrong. It's a myth. There are so many non-technical roles in the software industry, and someone, if they are inclined towards creatives, they can go do creative related work in the software. And if someone is good in talking, good in dealing with people, they can go and do the first line of support. And if someone is good in sales, there are sales opportunities in software. And if someone is good in providing some strategic leadership to an organization, such roles exist as well. Not every role is a coding role. This is the first thing anyone needs to be aware about. There are multiple non-technical facing roles as well, like testing a software. When a software is made, someone needs to check that it is working fine and it meets the requirement of the customer, and it behaves as it needs to behave in various situations. So software tester, it's a mix of for functional testing, you have non-technical roles, and nowadays we have automation testing as well. We'll come to it slowly. So for example, digital marketing, this is a huge ocean, and it is only say 10% technical and 90% non-technical. You just need to know the basics of how the internet works, and some technical details of how the HTML performs to optimize a website so that you can do digital marketing. Is a huge field, and there are various career opportunities available among SEO, and it is a non-coding role. So you don't need to sit in front of the computer all day staring at screens. So let's go into some specific software engineering roles, and let's discuss what they do. What does it involve? So for example, let's take the case of a front-end developer. What a front-end developer does: you go to a website, okay, and the website loads. It loads the, for example, let's take an e-commerce website, and it loads the screen that you see on the on your desktop or laptop or mobile, and you click on, if you add things on a button, you click some buttons and you add things to your shopping cart, and that you check out and order the product. For example, let's say Flipkart or eBay or even Amazon. So to design the screen, and there are, see, earlier there was one role called software engineer, but now there are more specific specialized roles. The front end role is different, the back end role is different, the DevOps role, the person who takes care of the server, the service, the way it has to respond to increased traffic. Every role is a specialized role. So a front developer, he uses some skills like HTML and CSS, cascading style sheets, and just JavaScript. And he has to write programs to render the page. Page means an user interface on devices like desktop, tablet, and mobile. So he needs to write the code so that the user interface is uniform across the device. We call it as omni-channel. So he doesn't deal with anything to do with data. He doesn't do anything to do with the backend stuff. He deals only with the design on the front end, what you see on the screen. This is the role of a front-end developer. And of course, there are things like performance optimization, optimized way to load the page. He has to code it in, follow some best practices, follow some best design patterns, so that the page loads in less number of time, so that the search engines, they will give you higher ranking. Everything is related. Every small thing, the decision behind the design decision between every small thing has to be thought through deeply, so that the page loads faster. If the page loads slower, the user will go to another, customer will go to another competitor's site, and the business will be losing money, and it will be losing on sales. So every little thing that the front-end developer does, he has to think about user experience, something called user experience. He has to think about his search engine optimized pages. So every little thing he has to do, it's a quite an involved decision to design code in the front end. So he uses technologies like HTML to render the content, the data on the front end, and he uses also something called JavaScript to interact with the backend system. I'll tell you what a backend system is. So front end is to render and code a nice user interface. Okay, a backend developer, what does he do? So, so when you talk about a front end developer, right? For example, you're going to an ATM machine, you put your card, and then the menu changes, and then you choose something, the menu changes, and then you click, you input your password, it says your wrong password or something. So all this rendering of information is done by the front end developer. So when you insert the card, to authenticate, does the card belong to you? To authenticate whether the PIN belongs to you, to authenticate whether you have money in your account, to check whether you have money in your account, to check whether you have adequate balance, and to transfer the money, and then update your bank account telling this much amount of money has taken out of the system. These are all taking place in the background. So to do all this logic, one needs to code in languages called say C# or .NET. There are so many different languages, Python, a language called programming language called Python. You can code in these languages, so that the money is taken out of your bank. So if you see this, if you see this picture, right, on the left side, we have a browser. User clicks on a button. User clicks on a button, and then the request goes to the server. This web server is a server. I just assume it as a box, like a CPU sitting in somewhere in the cloud, and then that will talk to the database, which will have all the information about the user, his account, amount of money he has got, everything. It checks against the backend. So there is some logic that goes behind the scene, and that logic is the coding of that logic, that program, is called backend development. And when you talk about web server, there is a specialized role called DevOps engineer today. So what a DevOps engineer does is he will ensure that whenever there are traffic increases, when more number of customers go and hit the site has to perform well with the same speed and optimal, when the request should not take too long to come back. All this science, all this engineering, a backend developer does, and especially in coordination with a software engineer called DevOps engineer. So DevOps engineer is the role of him is like the two explains. There's so much involved more than that, but for a basic understanding, I think this should be enough for you. And there is something called user experience designer and user designer, web designer as well. There is a role called web designer, and there is a role called user experience designer. So there is a subtle difference between the two. The user experience designer, what he does is he worries about user experience. If a user comes to your website, he should get all the information he wants rightly without scrolling. An example, and you should display highlight the relevant part of the website using relevant color text, so that he will scroll through, and then he will navigating. How does he navigate between one page to the another? All this user experience, user designer, UX designer, we call it the role. He thinks about it, so that the ease of navigating between the pages and finding out information that he wants will be easy. So, and then he gets what he wants. A user experience designer, web designer, what he does is he deals with the graphics part of it. Graphics part of, for example, if you have an image, if you go to a website, you see some, if you go to a BBC site, news site, you will see an image. So the image has to be optimized. It has to occupy less memory space, so that it downloads quicker. And these type of designing information is taken care of by the web designer. So this is one role. Web designer is one, and user interface design, UI designer, is another role. And there is a role called tester. So what does a tester do? So if you see this image, a tester has got a knife in his hand, and the developer on the left side, you have a developer, he has got an axe on his hand. What that literally means is the tester is trying to it really depicts a scene where people get he's trying to find faults with the software that's being developed, and he's trying to prove that it's not a fault, it is behaving as it needs to behave. So that is the scene depicted in this image. So what a software engineer tester does is he checks whether there's whatever you program that the developer, that is the front-end developer and the back-end developer in coordination, they have developed the software. But someone has to test that it does what it needs to do. When you log into a site, the dashboard has to show up. And when you click forgot password, you should be taken to a page where you input your email address, and then it sends an email address. All this has to be verified before the software gets shipped out to the end customer. So all this compliance and checking is done by a role called software tester. And this, to a major extent, it's getting automated today, where we write programs so that some of the mundane tasks that a software tester does is automated. But still there is something called functional testing. So that the functional testing part of a software is taken care of by a person called software tester. He is mostly human, and he does not do any automation testing. Major, say 80% is automation testing, but 20% the final testing is done by some person called software tester. So there is also a role called business analyst. So this is a non-technical role. As I was telling, not every role is a technical role. We have a role called business analyst as well. This is a purely non-technical role. Certain bits of it has some technical aspects, but mostly you can consider it as business analyst. So you need to be good at interacting with people, understanding a problem, understanding users requirement properly, and communicating it properly. So a business analyst, what he does is, suppose if you want to build a website, it's like building a house. Okay, someone comes and tells you, I want to build a house. Okay, you will ask the user, how many rooms does a house need to have? 2 rooms, 3 rooms, 4 rooms? How many kitchens does it need to have? How many bathrooms does it need to have? So this business analyst, he talks to the customer and says, he gathers the requirement from the user, telling he needs a website, it needs to have this, it needs to have these many products, it needs to have a feature to search for products, and it needs to have a feature to list the stock, and it needs to have a feature to make the payments, online payments. All this requirement of gathering of the requirement is taken care of by a role called business analyst. It's a non-technical role. There are some technical aspects to it as well, but consider it as a non-technical role. So this is a key important role, and he has to run the entire program. He needs to interact with various stakeholders in the business. For example, he needs to sometimes interact with the HR as well to monitor the hiring needs, and he needs to give inputs on the budgeting as well. He needs to report on monitoring the progress of the project. In some cases, it's an overlapping role. Some case there is a specialized role called Scrum Master, which is a project manager. I'll come to it in the next slides. So business analyst, he gathers requirements from the user and he passes on to the tester, development team. And if there is any questions or any queries from the developers, he interacts with the business client again to answer this question. So this is the role of a business analyst. Next, another role is called a project manager roles. Any project, be it small or big, needs to be managed. Otherwise, it will go out of scope. Defining the scope of a project, working on the budgets, working on the progress, informing the various stakeholders and higher management roles, management people, and also updating the end customer about the progress of the project. All this is done by a project manager. We also call him as Scrum Master. There are various names that are he is called as. Most likely what he does is he manages the project, he sets the budget, he manages the resources, he manages the time spent on the project, because some projects are budget bound, some projects are time bound, and some projects are something called time and material. So as long as it goes, you will be billing the customer to pay for the time. So all this needs to be very scientifically managed by a person called project manager. So one needs to be good in dealing with people. He needs to be a good communicator. He needs to be good with conflict resolution. All these are other attributes that are expected from a good project manager. And you should not micromanage as well. Nobody likes to be micromanaged. All this, the project manager has to be aware so that the project is successful. So this is another role in software engineer. Okay, so what are the skills that are expected from a software engineer? Very fundamental attribute that a good software engineer, that the industry expects from software engineer, he should be a problem solver. In day-to-day activity of a business, there will be so many problems, not personal problem. Even in the application, we have less servers, but we need to share it between the teams. We have some dependency from some team. So how do you solve them? One small example is it could be in the application, or it could be the problem with the people. So there can be so many problems. So one needs to be a good problem solver. And then we should look at solutions rather than just projecting the problems. So he should pay attention to detail. You see, if this is very important, if attention, for example, if we don't code the software in an optimized manner, it can take more time to execute. It can consume more resources to execute. Today in cloud world, the cost is related to the execution time the server takes. So he has to pay attention to detail in every small aspect of what he does. And he should be a clear communicator. So see, the software developer just not just code. He needs to talk to various people in the business. He needs to talk to various people within the team. Sometimes he need to talk to the customer as well directly. Sometimes he needs to travel as well to the customer sites. So you need to be you need to communicate your thoughts clearly within the team, within the stakeholders, and within the within the management as well at the right level. So there could be situations where you need to escalate things. Okay, so you need to know when to escalate and to what extent you need to escalate. You can't just escalate too early and too late. This is also part of the risk management. In a project, there are always risks. So you need to communicate the risks and highlight them when required. So he needs to be a good communicator. And that's why we insist on this Young Speakers Club in 3Meem Foundation that we are conducting to train them to be good communicators. And a software engineer needs to learn continuously. Learning is not a one-time job. You learn some skill and it might get obsolete in few years. It's an ongoing process. You learn one version, there is a newer version of the same software, and then the newer version of the software could be totally different. The concepts could be totally different than what you have learned. So you need to unlearn what you have learned and learn the new way. For example, in Java 8 was a major release. So things are totally different. So we need to forget what it was Java 8 version, and you need to learn the newer way of coding. So it is an ongoing process. It is not a one-time job at all. And you need to be a good team player. See, a software is always, there's a lot of teamwork involved. It is never a one-time process. One person does not do. You need to interact with different people, do different parts of the projects. So you need to cooperate with the team. Sometimes when someone is stuck, you need to go and help them out. And sometimes you need to do various roles that are outside your role as well. So you need to be a good team player, and you need to be empathetic to others. If some people have problems, they are slipping on deadlines, you can go and approach them and offer help and be respectful of them. The way you communicate, don't take things personally. Don't criticize things personally. Nobody likes it. Just highlight what is needed for the work. So you need to be a good with people as well. People management skill is also needed. So how to become a software engineer? First step is, there are so many different ways. We'll go one by one. You can become a software engineer by getting an IT degree. That is the most optimal way, but that is not the only way, I would say. Some companies insist on an IT degree. It could be anything. The best part of being a software engineer is, luckily, if you go to another country, you can still work. There are no regulations. No regulations in the sense you don't need to do some certification locally. For example, doctors, if you study in one country, you can't practice in another country. There are restrictions. They have to pass some local exams, some regulatory exams before you can start practicing or you can start working. But for software engineers, there's no such limit. You know a skill, you can go to another country and then you can start working there. So just imagine there are less boundaries for a software engineer. Get an IT degree. That is the first step. And second option is, you need not get an IT degree alone. You can get any degree. For roles that don't require specific skills, a basic degree is enough. For example, being a web designer, you don't need to have an IT degree. You can have any degree, but you need to have some creative skills and some skills to show off that you can do a good design. For being a software salesperson, for being a content writer, you need to have a basic degree in some English language, some humanities. That's all is needed. So to enter the software industry field, one need not have a software degree at all. But for some specific roles, having an IT degree gives an edge. And there are also some boot camps conducted by companies. What does it mean is, they take a problem and then they say, for 2 weeks or 3 weeks or 1 month, we are conducting a boot camp. So people who have the skills, they can just go and discuss the problem, solve the problem, build the solution, and then showcase to the end client, I mean, company who is running the bootcamp, and that way you are gaining more skills. So that is one route to become a software engineer. We also can do internships. There is a 2% tax rebate that government offers for any business in the UK to hire interns. So tap this route as well. In internship, you get more real-time experience. You solve more problems, develop actual solutions, and work with people to get real-time experience. So pursue a specialization. Don't just be a software engineer. After a time, you need to be, say, I'm a specialist in front-end, I'm a specialist in back-end, or I'm a specialist to develop mobile apps, or I'm a specialist who deals with servers, security aspects of the servers, performance of the servers. You need to develop a specialization. So you can pursue entry-level options where you go to and apply to a company, and there are various companies take entry-level jobs, and they offer some career training programs on specific skills that are needed for the performing the job. Get certified. There are various certification available for Java programming language, .NET, Amazon Web Services, Azure, or even some cyber security aspects as well. It is good to say at an entry level that you have certain certification than just saying I know Java or I know .NET to program in one particular language. Going with a certification gives you an additional advantage. Attend conferences. Earlier it was physical, but now it's virtual. On Zoom, sitting at your home, you can attend various conferences to know what is going on in the world and what is the most advancements happening in one particular field. Attend meetups. On every topic there are meetups organized. Just go and attend where some specialists come and talk on a particular topic, and you gain more knowledge in those meetups. And again, as I said earlier, do some specialization. Don't just be a software engineer, just a graduate. Specialize in one particular skill. You need to supplement your studies as well. Okay, today I need to highlight something about open source projects. It need not be necessarily be actually developing a software. There's something called stackoverflow.com. Go there. Other developers, when they have a problem, they say, I have a problem like this. I don't know what is the solution. Research a bit on that and answer the question. Similarly, even on GitHub, there are open source projects where you can contribute to that. You can develop a part of a problem, solve a part of a problem, and submit it to the project. And then there are more senior people in the who are part of the project who will review your solution. They will integrate your solution to the GitHub. So mentioning these things on your CV that you have this project, this is my GitHub. GitHub is a repository of code, software code, where you keep the software. And giving that on the reference to those GitHub repositories on your CV adds a lot of weightage. Go to sites like Coding Game and Code Wars, where you can solve small problems. That way you gain more experience, and that way you will improve the type of data structures. You will become a better programmer by going to those sites and then doing small exercise. They are called code katas. Kata is a Japanese term. You can solve small problems, and then you can improve the way you code. And talk to experienced developers. When I said about open source projects, when you go to their GitHub repositories, look at the way they code. See how optimally they are coding. Are they coding the way you thought to solve a problem? Or is there a better way to solve the problem? Look at those experienced developers code and learn from them. And develop projects, develop applications, small applications on your own. To just have an imaginary problem and solve it, and give a reference to a work you have done on your CV. That carries a lot of weightage. So in a typical day of a software engineer, what happens? Let's see, we are just comparing the roles of an entry-level software engineer and a senior software engineer. So on the left side is the entry-level software engineer. So he implements new features. Features could be change the color of a button. So this is called a feature, simplest term. And then changing the text in the login page, or changing the text on the dashboard. Changing the content could be just one feature. So he implements new features. He learns more features, and he also maintains existing code. If there is any bug, that is any error code that happens in the existing software, he fixes them. that's how he learns. He comes up to the speed slowly. And there is something called pair programming. Pair programming is a concept where two developers sit next to each other, and then they develop the software, they interact, they collaborate. That's why I mentioned earlier, you need to be very good dealing with people, and there should be very good communicators. So in pair programming, you need to communicate your ideas to the person who is pairing with you, and you should be good with dealing with people. Sometimes the person who is coding next to you may not be the best, most approachable person. So you need to know how to deal with such people as well. So that's why first attribute I said, you need to be a problem solver. So when you have a communication problem with your person who is pairing with you, you need to escalate it to the right extent, and you need to communicate your ideas to the person sitting next to you. And he also changes the existing code in the application to make it more efficient. Over a period of time, the code might get unmaintainable. So you need to make it efficient, because with time, the software engineering evolves. So old code, though it works today, if you see, it could be a different, totally outdated way of doing a particular problem. So you need to refactor, change the code, existing code as well. So a senior software engineer on the other side, he takes more higher level important decisions about the project, like deciding which framework to use, so for example, the same problem can be solved using Java, it can be solved using .NET, or it can be solved using Python as well. So which is good for this customer? So the customer existing applications can be running on .NET, something called .NET program. So if he is wanting to do Java, so he has to think about training the existing users. So it's a totally different ecosystem. So such decisions are taken by a senior software engineer. He also has to mentor junior developers. He has to guide the junior developers, sometimes involved in hiring of junior developers. All this work is done by a senior software engineer, and he also involves in planning the work. So it's a very scientific way of working. It's not just randomly going and coding. So software engineers, they divide their work, what needs to be done. So these many number of features need to be added. So in this week we will do this, in the next week we will do that. This is called sprint planning. So the senior software engineer, he assists in the sprint planning as well. And he also reviews the work done by a junior developer. That junior developer may not have coded the way something in the best possible manner. So he can say, okay, instead of this, do it this way. It is more optimized way. It will consume less memory. It will execute faster. Such suggestions the senior software engineer does. He does more high level decisions. The entry level engineer, he learns stuff and then he contributes towards the overall software development. So what degrees do you need to achieve based on your goals? So if you're already in an IT industry, and if you want to further your career, get a master's degree. And if you have no computer science background, but you want to enter into the computer science industry, get a bachelor's degree. Okay, bachelor's, it could be ideally IT degree, but it could be any degree as well. And finally, so if someone wants to become a software engineer, but he's not fully sure, before investing the time and money, he wants to try out something, so he can learn things online. There are so many online resources as well, where one can learn and then see whether he likes it. If he likes it, he can specialize into something. Otherwise, he can give up there. And if someone has an extensive industry experience already, and he wants to explore more, do more of research, and maybe he's got some interest towards academics, he can do a PhD. And on all these, right, these are all formal way. There are informal ways. Informal way is online route. You can study things online. There is something called udemy.com and coursera.com, where courses are available for say $30, $40, not very costly. And you can have the access to the videos for your life. You can play you can learn things at your own pace, play, replay, and then learn a particular skill online yourself. You don't have to pay for a costly physical class. There are online classes available as well. This route is best for upskilling. So these are some of the top programming languages as per 2019's survey. One is Python. So anybody who wants to learn programming, Python is a very good language to learn as a first step. Okay, for people who don't know where to start, Python is a very good starting point, and Java is one more very popular programming language that is in second spot as per 2009 survey. There are other languages, programming languages as well. You can just go through this slide later. So you can just, this slide gives the salary information of various roles, various other professions as well. And if you see information technology is at number 7, which is as good as being a lawyer. And this data is based on 2016. The latest data is different. We can just see that it is a more rewarding role, and there is good money to be earned as well. And you can just compare with other professions as well. It pays as good as any other profession, as lawyers as well, and it pays better than some professions as well. And in the STEM field, which pays higher? This slide gives you the details. Top being mathematics, and where is software engineering? Third from the last, computer science. So it pays more than life science, statistics, electrical engineering, pharmacist, or being a mechanical engineer. It pays more than that. It's just a comparative study. The latest results could be slightly different. An average entry-level salary and a senior software engineer salary. This slide gives in various countries. If you see the last line, UK, it gives 40K, which is roughly say 32K in UK. But this is in the top end of the industry. This is not the, some companies pay say 20, they start at 20K even, some small companies. This 32K is some higher, bigger companies, bigger e-commerce companies, retailers, they pay 32K at entry level upfront itself, but you should be from the top universities. And a senior software engineer, the salaries just compared in this slide from various countries. You can have a look. The slides will be circulated later. And these give the salaries for various skills. Again, the first ones gives for Java. And this is for top end of the industries. Not every Java developer gets this salary. Some industries like banking, investment banking, they pay this amount of salaries. Just a comparative salary study of various skills. This is the iOS developer, the third one. And then the fourth one is the Android developer, and this is a front-end JavaScript developer. And the next two are C and C#, .NET programmer, and the last is PHP. For small websites, one can use PHP programming language, and this gives a comparative study of what skill pays you how much. This is as per the January 2020 data in UK. So, and it's not about coding always, being a software engineer. You need some soft skills as well. What are the soft skills? You need to have a good leadership. Sometimes in the project, for one particular issue, you need to take a leadership to give a solution, to lead, to resolve a problem, to find out what is the problem in the software, or what is going wrong. You need to provide leadership to the team. You need to mentor some junior developers in the team, and those soft skills you need to have. You need to have good technical skills. Don't just stick to one or two programming languages. Diversify your array of skills you have as much as possible. You need to communicate well within the team and inside the business and outside the business as well. You need to be emotionally intelligent. Don't be so, don't take things personally. Everything that is being said and done is done for the business. And you need to be delivery focused. There will be very tight deadlines. You need to be delivery focused, and you need to schedule your time, and don't expect to be micromanaged. Given a task, given a time, just finish it and manage your time accordingly. You need to have very good business knowledge. You need to, unless you have a very good understanding of how the business is functioning and where it is headed to, that will help you develop better solutions, better solutions for the given problem. So this is the career progression of a software developer. He starts as a software developer. He progresses on to become a senior software developer, and then he becomes a technical architect, and then he branches out either to a technical field or a non-technical field. So if you can become an architect or a senior architect. If it is a non-technical people manager, he can become an engineering manager, and then he can go on to become an engineering director as well. And there are various roles beyond this as well, but this is the typical stack for the, say, 0 to 5 years to 5 years in one's career. And beyond this, one can grow on to become a CTO as well. And some of the emerging technologies in today, one is artificial intelligence. Things are getting smarter and smarter and smarter. For example, in your home, you might have found something that controls the temperature that of the regulator of the radiators. So there is artificial intelligence built into it. The devices are learning over a period of time based on the historical data. So this is one area that is already emerged, but it is getting better and better and better every day. I'll just, we have less time, so I'll just touch upon a few things. IoT, it means Internet of Things. Devices are connected today. So today you can have an app that controls the temperature of your home before you go home. So this is possible because of something called Internet of Things, where devices are connected and there is a software and application that controls everything. Everything is controlled by software. So developing such software is one emerging field today. There's something called serverless computing. In Amazon, there is something called Amazon Web Services, where there is no physical server. Servers are all virtual and in the cloud. So this particular area is getting more specialized today. And developing artificial virtual reality applications because today, if you see, it's a COVID situation and we can't go to places physically and we have to view things virtually. So you need software, you need to write program software, you need to develop software for such virtual reality solutions. And natural language processing, for example, speech recognition. One typical example is, in YouTube, if you upload a video, the video gets the text of it, text for the YouTube video, there's an option to auto-generate it. And the software needs to understand that. This natural language processing is what does that. That's some small example of natural language processing. This is, again, there are different things that can be developed because just based on this concept. This is another area of emerging today. So last slide, I won't take much time. So how to find an IT job? Prepare a very good CV. For a job, there are, say, 25 applicants that are 25 to 30 on an average. They apply to the job. Only 4 get the interview opportunity and 1 gets the job. So how does the 4 stand out from the 25? It's because of the CV. Write a proper CV, write on your achievements, write on your skills, write on your volunteer experience properly, so that your CV stands out from the rest of the application. This one particular thing is we can have a separate webinar on that probably, how to write a good CV and how to stand out from the rest of the people. Apply in more than 1 job boards. Don't stick to 1 job board, because each industry has 1 job board where such jobs, academic jobs, get posted in 1 job board. IT jobs get posted in another job board. So diversify your search. In universities, mostly there'll be career placement programs. Attend them, and then the employers, they visit your campus and they conduct some recruitment fairs and they hire people. Network with people on LinkedIn, and you can connect with recruiters directly, and you can contribute to some conversations in an engaging way. And when people ask questions, just answer them, and then that gives you better profile and better branding. Showcase your work, whatever you do. For example, for design for people, if you do something, have your online portfolio and give a link to your online portfolio on your CV. It is when people add such things on your CV, they stand out from the rest of the candidates who write mundane things, mundane roles and responsibilities. Rather than that, write achievements, give statistics. Just instead of telling I improved the performance, just say I improved the performance by 10% or 20%. That makes more impact. And the last point, there is something called a return to work program. This is applicable for women. Many big corporates, they run something called return to work program. What it is, they encourage women to return to their workplace. Somebody might have taken break for family reasons, having a baby, marriage, or whatever reasons. So to encourage such women to come back to work, they conduct some return to work programs where they offer formal training so that the people can upskill and then come up to speed to what is needed because they have had a break in their career. So keep a watch for Google for return to work programs. Sky offers this, BBC offers this, big corporates offer it. you make use of it, and it's an easier way to return to work than since you have had a career break. And that ends my talk, and we can have questions now. The floor is open for questions. If you have any questions, type on the chat box, and we can go through them one by one and answer them. Thank you. Does anyone have any question?